Let's take a look at this problem and use MATLAB and Python in order to solve it. Given a quadratic equation with coefficients a, b, and c as written below, ax squared plus bx plus c equals 0, write a program that will look for its roots. To solve the problem, we need to use the quadratic equation as shown. X equals negative b plus or minus square root of b squared minus 4ac over 2a. The term inside the square root is called the discriminant. There are three cases for the discriminant. One in which the discriminant is equal to 0, another in which the discriminant is greater than 0, and another in which the discriminant is less than 0. In the first two cases, the square root will give us positive results. But in the last case, the square root will give us a negative result, resulting to a complex root. Also, you need to take into account that a is in the denominator, which means that a cannot be 0. Otherwise, x will have an undefined solution. So let's consider all of these results. Here in our script, we'll type in clear CLF and CLC. Although in this case, we don't really need CLF because CLF is for clearing a figure, but we're not going to plot out any figure. The next is we're going to define our coefficients. So let's say a equals 1, b equals 2, and c equals 3. After defining our coefficients, we'll now type in the equation for the root, which is x equals negative b, okay, plus or minus plus sqrt of the discriminant. So let me type this here for the discriminant, and then I have to enclose this, all of the numerator in a parenthesis, and write the denominator as shown. So this will be x1, and another solution will be x2. Okay, now I have to define the discriminant. Otherwise, this will not work because the discriminant, because x1 needs the value of the discriminant, and x2 also needs the value of the discriminant. And if there's no value for the discriminant, then the program will not work. So b squared minus 4 times a times c. Okay. Now that I've written the value of the discriminant, okay, let's consider how we are going to write those three cases. So I'm going to show you a new command called if. If is a command that we can use if there are certain conditions in our operation. So the command is just simply written as if, okay, and then the next thing that we type in is the condition. So the first thing that we type in is if a is equal to 0, okay, and then you can see that after I press enter, MATLAB automatically introduces an indent. Okay, so if a is not equal to 0, then this one will have an answer. So remember that we have three values for three solutions. One in which the discriminant is equal to 0, this one in which the discriminant is greater than 0, and another in which the discriminant is less than 0. So let's first consider the case when the discriminant is equal to 0. So again, we're going to find a solution. here a is equal to 0. So if a is equal to 0, that means our solution is negative c over b. And now I can type in or type out that solution as so. The solution is %.2f backslash n period. And then, okay. I now introduce you to another new command which is called fprintf. This is the same as in the print command in Python. So in order to show some text and a numerical result, we need to use the command fprintf. Notice that instead of using open close quotation, open close double quotation, as in Python, in MATLAB we use single close quotation. So we have a single close quotation here, and then a single close quotation here. Okay, here's the text, the solution is. Now here is where I represent the number. That number is sol, which I write here after the comma sign. This means that this number sol will be written as first as a floating point, which means it's not an integer. Also, it'll also be written with 2 decimal places. So in other words, if the answer is 3.14159, then it will just show 3.14 because I wrote 0.2 here. The percent sign tells MATLAB that what happens or what is written after the percent sign is this value here. Okay, and then after the f we have this /n. This means simply a return carriage or a next line. Okay, so this is the solution if a is equal to 0. What if the solution is a not equal to 0? Then we're going to write next else if. Okay, else if is another command which is a subset of the if command. So our first condition here will be disk is equal to 0. And if disk is equal to 0, our solution is equal to negative b over 2 times a. Then we also print out that solution here. Okay, now otherwise, or in MATLAB, else if, or in MATLAB we can type just else. So this is the last condition that we need to write in. We say that x1 is equal to negative b plus or minus plus squared this 2a, and then x2 is this minus sign. Okay, and then I also type in this fprintf. Just copy this here. Okay, now since I have 2 solutions, I need to write these 2 solutions here. So what I'm going to do is I'm going to type it like this, plus %.2f I and %.2f minus %.2f I backslash n. Okay. And then you notice that I need to write 1, 2, 3, 4 floating point numbers corresponding to the real solution of x1, the complex solution of the imaginary solution of x1, real solution of x2, and the imaginary solution of x2. So real solution of x1, imaginary solution of x1, real solution of x2, imaginary solution of x2. Okay, if this line is too long, what we can do is place 1, 2, 3 dots here and then press enter. Okay. By placing 3 dots here, we tell MATLAB that this is still included in the same command. Okay, now to terminate the if command, we need to write the command end. Okay, now notice that even though there are 3 conditions for disk, I combine the 2 conditions here in this in these 3 statements. So these 3 statements factors in real solutions and complex solutions. Okay, now let's run this code. So I'm going to press run. Okay, and then I will need to save this file. So I'm going to say roots. Okay, and after saving, it should run. Now let's go to the command window. For a equals 1, 2, and 3, this will give us a complex solution. And voila, we have a complex solution. Now the problem here is that since the complex solution of the x2 is negative and we have a negative sign here, they don't cancel each other out, or they don't multiply. Okay, so maybe you have a better solution than I have. Okay, let's change this to 1, 2, 1. If I have 1 to 1, then the roots will be, or the solution is negative 1. Okay. If I have 1, 3, 1, then the root will be 0.38 and then negative 0.262, indicating that the solution is real and not complex. And then if I have 0, if I set a to 0, set this to 2, then our solution should be negative 1/2. Okay, as shown. This is what it looks like in Python. Notice that the first line that I need to include is this import command. So I need this import in order to be able to use the complex library, complex mathematics library. I also defined A here, B here, and C here. Then I defined the discriminant here to be b squared minus 4ac. Okay, the if command, okay, is written like this. In Python, you type if here and the condition here. Instead of writing the first condition as a equals 0, I wrote it as a not equal to 0. This is how you write not equal to. Okay, so this means that a is not equal to 0. So if a is not equal to 0, okay, then you write a colon here. It's important to write the colon after this command or the code will not work. Okay, so if a is not equal to 0, the first term, okay, or if a is equal to 0, then I have to solve for the discriminant. Otherwise, or else, if a is equal to 0, then I can print out the solution like so. Okay, so now if you notice that I have 3 conditions here, 1, 2, 3. The first condition is when the discriminant is equal to 0. The second condition is when the discriminant is greater than 0. And the third condition is when the discriminant is less than 0. Also, you notice that here we use, in Python we use elif, but in MATLAB we use else if. Okay, so if the discriminant is equal to 0, then I print out this solution. Okay, how do we print out the solution? We use the print command followed by an open parenthesis, and then it's followed by a double quotation, and then the solution is, then the solution is, and then space, and then double quotation, and then to add the numerical value, I type down here. Here is the numerical value, which is the first term. But if we just use first term here, Python will produce an error. So I have to use the command string or str. This converts the first term, which is a number, to a string. So this command converts a number to a string. Okay, after Python converts this to a string, then it can be added or appended to this sentence. Okay, after the string, then I have the plus sign here to add the dot here. Now, if the discriminant is greater than 0, I have these two solutions. Okay, notice that the square root function here, okay, calls for the CMath library, okay, or is included in the CMath library. Okay, so in this case, I write the solution as like this one. So again, we need to convert the numerical value to a string. Also, I have to write down, I rounded off the numerical value before converting to a string. So I round off x1.real. Now what is this x1.real? This means that I'm taking the real value of x1. This is how you write it in Python. In MATLAB, if you recall, you write it as real and x1. Okay, but we don't have that command in Python. Instead, we write it x1.real. And we know that this is for the round command, which means that it will give us 2 decimal places, then plus end. Okay, and then if we go further down, then we have this solution, okay, for the x2. Python doesn't have the same command as if you want to continue this sentence in the next line. In MATLAB, if you recall, we have to place 3 dots and it will go to the next line. But here in Python, you see that it's an invalid syntax, which means that it doesn't recognize those 3 dots to be any type of command. Okay, so we have to stick with this very long line. Okay, now this third condition corresponds to the condition when the discriminant is less than 0, which means that the square root is complex and the solution is also complex. Okay, now let's try to run this program. So if I click here, you can see that for A1, A equals 1, B equals 2, C equals 3, the solutions are -1 plus 1.41j and -1 minus 1.41j. J is also sometimes used as the imaginary number or equal to square root of 2. If I change this to 1, 2, 1, we know that it will give us a positive solution, I mean a real solution, which is -1. If I change this to 1, 3, 1, it will also give us the solution or a real solution. And if I set this to 0, change this to 2, we get 1/2.